Anytime we talk about digital logic circuits, we're supposed to keep in mind that every single input of any gate has to be connected somewhere. I mean, has to be connected to VCC, to ground, or let's say to the output of the other gate. I drew a few examples on the board, and I want to verify together with you which connection, right? Which connections are correct in order to make 2-input AND gate from 3-input AND gate, or let's say 4-input AND gate. So let's verify what happens in this circuits. First gate, we have 3-input AND gate. As we said, we cannot leave one of the inputs or many inputs, but in this case we have just one extra input open. Okay, why we do this connection? Because sometimes at particular moment you do not have 2-input AND gate, but you have 3-input AND gate. So you're supposed to know how to connect the circuit together in order to make 3-input AND gate 2-input. So I made the connection of the first input with the second, and let's check if this is correct. Okay, so I have A and this is B. Okay, so simply I can say that this is nothing else, just the product, and I have A times A times B. Okay, so we have A goes to both inputs, goes over here and goes over here, and I have over here B. And don't forget that AND gate represents the algebraic, or we can say Boolean multiplication. So we have A times B. A's and B are variables. Okay, so A can represent 0 or can represent 1. Okay, so if I have A times A, so it could be 0 times 0 or 1 times 1. So 0 times 0 gives me 0, 1 times 1 gives me 1, so A times A gives me A times B. Okay, so my output is nothing else, just A, B. And this is the logic expression for the AND gate. So I can say that connection made like this is correct connection in order to make 3-input AND gate 2-input. Let's take a look at this gate. Okay, I made connection like this. I connect these 2 inputs together and connect to A. So this is the same story. This A will go over here, and I have A, and I have A, and I have B. Don't forget that this is AND gate. This is multiplication. So I have A times A times A times B. Again, we talk in terms of variables. These A's can represent, let's say, 3 zeros or 3 ones. Okay, so 1 times 1 times 1 is going to give me 1, right? 0 times 0 times 0 gives me 0. So I can say A times A times A is equal A times B. Okay, so this is my output logic expression, A, B. And this is nothing else, just the logic expression of 2-input AND gate. Let's take a look at this gate. We have pull-up resistor. Okay, we're going to discuss pull-up resistors later on, but it simply means that we have VCC, and VCC represents logic high. So high is connected to this input. And I have A over here and I have B over here. As we said, AND represents multiplication. So I have 1 times A times B. 1 times A times B is nothing else, just A, B. So my output is going to have logic expression A, B. And this is nothing else, just 2 input AND gate. So this connection is also correct. Okay, so you can connect 3 input AND gate like this, okay, by connecting one of the inputs to VCC, and you are going to create 2 input AND gate. Let's take a look at the next gate. We have again pull-up resistor, that's why we're going to have 1 and 1 over here, and I have A, B. Again, this is multiplication, so I have 1 times A times B. So we have 1 times A times B is nothing else, just A, B. Logic expression at the output is going to be AB. And this is nothing else. Again, this is 2 input AND gate. Now let's take a look at this gate. We have A, B, and the third input is connected to ground. Ground is logic 0. Don't forget that AND is multiplication. So I have A times B times 0, right? So A times B is AB times 0 is equal 0. So at the output we are going to have what? 0. So this is not logic expression for AND gate. So that's why this connection is incorrect. If you will follow these procedures, you are going to be able to create AND gate with any amount of inputs. But just keep in mind, you cannot leave any input open. Okay, so right now let's talk about the NAND gate.